So in secondary storage, the data is not sorted. So the data is not sorted on the basis of key. So you can see here that the data is not arranged as per the search key value, and also the search key field can be a key or it can be a non-key. So duplicate value is also possible in secondary indexing. But the index record which we made, in that record the data is sorted. So this is the index record. Just a minute. So data is not sorted on the search key value, but the index file which we made have records sorted as per the index key. So while we are searching, we can apply binary search on the index record, even in case of secondary index. So the last classification of indexing is clustering index. And clustering index also, the search key is a non-key field, so we can have duplicate value in the search key field, but the record is sorted on the basis of the search key. So if we are creating the index on this field, then this field should be sorted. Also, the record is also sorted on the basis of search key value. So we have three type of indexing: primary index based on primary key, record is ordered. Secondary index can be based on candidate key or non-key. The record are unordered, but the index file is ordered. Remember this: index file, whether it is secondary, primary, or clustering, index file is always sorted. This is the record we are talking about. So records are unordered here. Records are also ordered in primary key, and records are in order in cluster index. So these are the three classification of indexing. Now let us do some example based on indexing. So this is an example. So we have an ordered file of 30,000 records. Now these files are stored in a block of size 1024 bytes. Now record are fixed size and each record size is 100 byte. So if we calculate the blocking factor, it will be the size of the block divided by size of each record. So it's come out around 10.24. Now since the record is stored in an unspanned manner, so we cannot store fraction in a block. So the blocking factor here will be 10. So blocking factor is 10. That means we can store 10 record in a block. Now suppose we have to create a primary index on the key field of size 9 bytes and a block pointer of 6 bytes. So if you remember the structure of index file have a search key and a pointer. So here search key is 9 byte and pointer is 6 byte. So the size of one index record is 15 bytes. Now the question is, how many block access do we require to search a record if we are storing the data without indexing, or if we are storing the data with index? So let us see what happens if we store the data without indexing. So remember the blocking factor is 10. I'm removing other things. So blocking factor is 10. So we can store 10 withdrawal in a block. So to store 30,000 withdrawal, how many blocks we require? Block required. We have 30,000 withdrawals and 10 withdrawals can be stored in a single block. So the block required will be 30,000 divided by 10, that is 3,000. So we require 3,000 blocks. We require 3,000 blocks to store all the withdrawals. Now we are using ordered file scheme. So these record will be stored in a sorted order. And if we are not using any indexing, then to search a record we need to search in complete block. Okay. So if we are not using any index, then we need to search in 3000 block. And since the record are sorted, we can use binary search. And in binary search, the number of block access required is log base 2 the number of block. So the number of block access required is this much if we are not using indexing. Okay. So blocking factor is 10. Total number of block required is 3000. And since the record are ordered, therefore the time the block access required is log base 2 and number of block. This is because we are using binary search. Now let us see what happens if we use indexing. So again, for indexing also, blocking factor will remain 10 and block required will be 3000. So we require 3000 block to store all the record. But when we are using primary index, we does not search the record directly in the block. We maintain an index file. So index file will have a search key value and pointer. Now since we are using primary key index, so in primary key and sparse index, what we do, we keep a pointer for just the first record of each block. Okay, we does not keep index entry for all the record. We just keep an entry for the first record of the block, and that record is called anchor record. Okay, so since we have 3000 blocks, so number of entry in index file will be 1 entry for each block. The number of entries in index file is 3000 and size of index record we have seen in the previous slide. Size of index file is this. Let me erase this. So size of one index record is 15 byte. So how many index record can we store in one block is 1024 divided by 15. This is near about, I think, 68. So these many index record we can store in one block. So how many block we require to store all the index record? The number of block to store index record. So total number of index record is 3000 divided by 68. So this is around 44.11. So total number of blocks required to store all the index record is 44.11, that is equal to 42. So we require 42 index record block. Now the searching is done in, when we are using primary index, searching will be done in index record, not directly in the block. So the number of block required to store index is 42. So the block access will be log base to 42. Okay. So the number of block required to store record is 3000, and we are using one entry for each block. So number of entries in index file is 3000, and number of block required to store 3000 index entry is 44 blocks. Sorry, 44 blocks. So this will be not 42, it will be 45. Okay. So index record size is 15. Number of index record per block is 68. Total number of index records is 3000. Therefore, the number of blocks we need is this much. And this is the number of blocks. Why we have used one here? So we have index record here and data file here. Index record point to the block, and when we get the block we need to search within the block. Okay, so we will access these block to find the index pointer, and once we find the pointer we need to access the data. So this one block access is for the data block. Now the same question we need to perform with secondary indexing. So if we are not using secondary indexing, the blocking factor will be same. We are using a span. The only change here is that since in secondary index the record are unordered, unsorted. Remember, in secondary storage, the records are not sorted. So we cannot apply binary search here. We need to apply linear search in case of secondary index. Therefore, if we are not using indexing, then the number of block access without indexing is not log base to 3000, it is 3000 because we have to use linear search. Now similarly, if we apply indexing, then the number of block required to store data is, since in secondary indexing we are using index entry for each record. So the number of index record required while using secondary index is equal to number of record. While in primary index, we require one entry for each block. So number of index record is equal to number of block. But in secondary index, we require index entry for every record. Therefore, number of index record is equal to number of record. So total we need to store 30,000 index record, and size of each index record is 15 byte, and blocking factor for index record is 68. So number of block required to store 30,000 index record is 441.176, that is approx 442. Now remember that data is unordered in secondary storage. If you remember data is unordered but the index is ordered, and we are performing searching on index file. So if we are using indexing in secondary index also, we need to search in this block only. We do not need to search in the data block. We need to search in index block, and since index block is sorted, we can apply binary search, and for binary search the SS time is log base 2 number of block, that is 442, and this one SS is when we find the pointer. We need to say, I will say we are performing. So we are performing searching in this. We are performing searching in this file. What is it? We are performing searching in this file. Say we find the search key value as 20. So in order to access the data, we need to access this block also. So the one there is to access the data block. So the total block access required in secondary indexing is log base 2 442 plus 1. So this is all we need to cover in